Hello everyone. In this video, I think we're going to talk about an important topic, which is going to be on how to write ionic formulas for ionic compounds. So an ionic compound basically involves ions. So it's going to involve a positive or positive ions and some negative ions, okay, or cations and anions. And you write them in that order. The cations always come first, the positive ones always come first, and the negatives always come second. I'm going to hand you guys out a sheet, and it's called your ion sheets. And whether I hand it out or you look it up online, it's up to you. But anyway, when you have this contains all the ions, and all you got to do is look up the answers and then follow a few simple math rules, and you're just fine. Okay, so again, this is all about looking up the answers and then combining them using some simple math rules. So if we take a look at this, if I have sodium chloride, how do I write sodium chloride? Okay, so the compound of NaCl is like this. Now that's a correct answer, but how did we get that? Well, when you look up the sodium ion in your ion sheet, you're going to notice it's Na+. And then when you look up chloride, now notice it's no longer chlorine, but it's chloride, you notice it's 1-. Okay, you want to get the pluses and minuses to match. In this case, they do. So it's +1, -1. They match. So I just need one of each. Since they both match, I just need one of each, and I end up with NaCl. That's my ionic formula. Okay? Essentially, it's as simple as that. So if I'm going to write the formula for binary compounds, here we go. Let's try a couple. So on your ion sheets, look up calcium, and you'll find that calcium's 2+. Okay? If you look up chloride, we just used it, it's Cl-. Now, the pluses and minuses don't match. We actually need to double our minuses. By the way, you can only add, you can never take away. So I have Ca2+, I have Cl-, so I need another Cl-, and it's legal. We can do that. As a matter of fact, that's what nature does. So nature says we're going to use 2 Cl- to match the 1 Ca2+, and now we can write a formula based off of this, and the formula says I have not just 1 Ca, but I used 2 Cl-, so I write it as a subscript. Now you're going to say, Kinkoff, where did the pluses and minuses go? They're still there. We just don't write them in the final formula here. We just write them as a ratio of 1 to 2. And notice I don't need to write the 1. I just use the 1 and the 1, 2 here. Okay? Try sodium sulfide. Okay? With sodium sulfide, now I have Na, which we used before, is +1. And the sulfide, when you look that up, it's 2-. So it doesn't matter where the pluses and minuses are. You always have to match them up, and you can only add to do this. Well, again, I don't want to take away. I just said I have to add. So I have 2 minuses, so I need another Na+. So I'm going to use 1, 2 of these and just 1 of these. So to get a formula, I'll use 2 of these and 1 of those. And that's writing a binary formula. Let's keep going here. This is fun. Okay, so aluminum oxide. This one's a little bit more complicated. You might want to pause the video, see if you can't figure it out. 3+, oxide's 2-. Oh, geez, this is terrible. Okay, 3 pluses and 2 minuses. The lowest number 3 and 2 both go into is 6. So I got to get 6 pluses and I got to get 6 minuses. That's the only way, because again, the rule is you can only add things, you can't take away or divide or anything like that. So I have to use another Al3+ to give me 6 pluses. Do you see that? And in order to get all the oxides to cancel out, I need to use a total of 3. So therefore, there's my 6 pluses, and here's my 6 minuses. In order to do that, I use 2 aluminum ions and 3 oxide ions, and that's my final answer. Magnesium phosphide, same type of problem here. Magnesium's 2+, you can look that up on your ion sheet, and phosphide's 3-. So again, it doesn't matter how you do this. I need to make sure that the 2 and the 3, which are both divisible by 6, I need 3 of the magnesium ions and just 2 phosphide ions. That gives me +6, that gives me -6. I used 1, 2, 3 magnesium ions to do that. So that's Mg3, and I used 2 phosphides to do that. That's Mg3P2, and that's my final answer. Okay, so those are writing binary compounds, and again, binary means it's just 2 things. Okay, in each case, I just was using 2 different elements. Okay, now it gets a little bit more difficult when I start grouping in polyatomic ions, so I want to talk about that real quick. So let me bring up a fresh slide here, and let me throw out some answers here. excuse me, throw out some scenarios which we can come up with answers for. So for example, if I have sodium, that's a +1 charge, look up nitrate. On your ion sheets, you'll find that nitrate, and by the way, be careful because there's also nitrite, but nitrate is NO3, and it happens to have a -1 charge. Okay, now, the Na, I have one of those. I'm using one, and I'm using one nitrate because they both match a +1, -1, so your formula is just NaNO3. Not bad. Okay, now, what if I have, let's do this one. Let me use sodium. Let's go back to sodium. And if I have one of those, and now I'm going to use sulfate. SO4 is sulfate. It's always SO4. SO4 is sulfate. You got to keep that together. But it has a 2 negative charge. Okay, just like before, I have to match up the charges. You can only add. You can't take away. Well, with 2 minuses here, I got to use another Na plus to make the +2 match the -2. In order to do that, I ended up with Na, but I used 2 of them, and 1 sulfate. So there's 2 of these, and there's 1 of these. Okay, notice I'm using this as a group of SO4 called the sulfate ion. Okay, let me go one step harder. What if I have Ca, the calcium ion? Let's go back to nitrate, and it doesn't matter what I use. All right, now this is an interesting situation because now I have 2 pluses and I have just 1 minus here. So what I need to do is add another nitrate. I have to add another NO3, okay? So with that, let me just get rid of that. That was confusing. So now the +2 matches the -2. But in order to write this correctly, I need to use 1 calcium and 2 nitrates. Notice what I did there. I put the whole polyatomic ion and preserved the NO3 together. Okay? I put it in parentheses and put the 2 outside. So again, let's try another one based on this little more complicated version here. Okay? So let's do aluminum. That's the aluminum ion. And let's use perchlorate. So perchlorate is ClO4 minus. Okay, it has a -1 charge. So in this example, I'm going to stick with my 3 plus on the Al, but I need to use a total of 3 perchlorate ions. So my final formula, which I'll write in red, is I need 1 aluminum, but I need 3 ClO4s. Notice how I say it real quick because it's together. It stays together, and I preserve that togetherness by using parentheses. Okay, let's try another, and this will be the last one. This will be the hardest one I'll do today. Okay, let's say I have magnesium. So you're looking up magnesium. That's on your ion sheets. Magnesium is 2 plus the magnesium ion is, and we're going to look up phosphate. That has a -3 charge. Well, the math is the same as what we did before. We just have to be careful with the phosphate. So between 2 and 3, they both go into 6. So this has to be +6. So I have to use a total of 3 magnesium ions. There's your +6. And I have to use 2 phosphate ions. To write the formula, and I'll write it in green, the formula is that I'm using 3 Mgs. Notice no parentheses because it's monatomic. And PO4 2. Okay, so to wrap up this portion, again, I'm only writing formulas. I only use parentheses, and here's the phrase, for multiple polyatomic ions. Multiple polyatomic ions. So if I have this particular situation where I have calcium plus sulfate, they match. The 2 plus and the 2 minus match. So I don't need parentheses here because this is a singular monatomic ion, and the answer is just that. Okay? Because I used 1 of each, 1 calcium and 1 sulfate. So only parentheses on multiple polyatomic ions. Okay? The last thing I'll talk about are these Roman numerals, and don't let these confuse you. Actually, they help you. So with Roman numerals, I already did that. So with Roman numerals, very, very simple. You just have to get used to these, and that's why you have your ion sheets. You're going to look up every single ion in the beginning. So things like manganese have multiple ionic charges of +2 and +3. It could be either one. Again, you have to look that up. Guess what? This is called manganese 2. This is called manganese 3. Iron can be plus 2 or plus 3. This is called iron 2. This is called iron 3. What's another one? Copper. Copper 1 and copper 2. Okay, notice the 1 and the 2. So this is going to have the name of copper. The plus 1 is going to be called copper 1. This is going to be called copper 2. Okay, this is called copper 2. This is called copper 1. Okay, you just have to look them up. Okay, I'll say it again. You just have to look them up. The Roman numeral matches the charge. The charge is the Roman numeral, etc., etc. So if I'm going to make up a couple of these, why don't we write a formula for, let me look one up here. Why don't we use iron 3 chloride, okay? So iron 3, don't even look it up. It's iron 3, so it's Fe3 plus, and chloride's a minus. Okay, I looked up both of them. I know iron 3 is 3 plus, and I have to triple, so just apply the same rules as we've done before. So I used 1 iron, and I used 3 chlorides to do that. So the 3 pluses match the 3 minuses. I just had to use 3 chlorides to get the 3 minuses. Okay, let's try one more at least, maybe 1 or 2 more actually. If I have copper 2, let's go copper 2, sulfite. Okay, so copper 2, you got to look that up. Don't bother. It's Cu2 plus, copper 2. Sulfite, I would look that one up. We haven't used that one yet. That's 2 minus. Notice they match. The 2 pluses and the 2 minuses match. So just write the formula. You're going to use 1 copper and 1 sulfite, CuSO3. Okay? And one more. Why don't we try nickel 2 carbonate. Nickel 2 carbonate. Okay? I'm just making these things up. I don't even know if they exist. Nickel 2 is Ni2 plus. Okay, so I looked that up real quick. And carbonate. Carbonate is CO3 with a 2 minus charge. Okay? Actually, I'm going to change that. Let's not use carbonate. Let's use nickel 2. Oh, here's a good one. Hydroxide. Okay? You guys always miss this one or mix it up. So nickel 2 hydroxide says that I have 2 pluses and only 1 minus, so I have to use 2 whole hydroxides. Now, nickel 2 hydroxide, the hydroxide is a polyatomic ion, so you must preserve it and say that I want 2. You confuse this because you don't have any cute little numbers down here. They're both 1, okay? So again, parentheses is necessary with hydroxide. The other one that gives you trouble is also cyanide because it's the same thing. It's a 1-to-1, okay? All right, I'll finish there. And again, if you have email or if you have questions, email me, contact me within class. We'll go over this in class.